I know what you're thinking. You have so much data and you need to send all of it up to the cloud for analysis. Is there a tool? Well, there's a company who can show you exactly how to do it. We walk step by step with them. That's what we're going to talk about, that solution on this Microsoft Dev Radio. Hi, and welcome to the next episode of Microsoft Dev Radio. I'm Jerry Nixon, and I'm here with a great set of guests, but I want to start with some of our evangelists that we have on the call because it's just a great time with these guys. James Sturtevant, now he's in Boston. We've had him on the show before. One of the smarter guys that I know, one of my favorite evangelists. James, thanks for being on the show today.
Thanks so much, and you're so kind.
Yeah, that's right. Tell me a little bit about Boston. How are things going?
They're going pretty good. It's pretty warm here this time of year. It's I think it actually is raining the last couple of days. So
pretty warm here this time of year. Yep, we're talking about January.
Yep.
Okay, cool. Now, my other favorite evangelist, Nick Landry in New York City, not so far from you, James. Nick, thanks for being on the show today.
Hey, my pleasure. It's good to see you again, Jerry.
Yeah. How are things going in New York City? Is it the hot time of year for you too?
Yeah, it's actually a lot milder. Well, I'm actually in New Jersey, maybe an hour west of New York. But yeah, it's kind of warm, especially since my Canadian-ness, is just not used to this non-snow winter that we're having now. So I miss the snow.
Yeah. Well, we still have snow in Colorado, so if you want to come for a visit, you're always welcome.
I should.
All right, so today we're going to be talking about RockStep and starting with some of the representatives there that are here. So I'm going to start with you, Keith. Keith Sheppard, you are in, where are you? You're in Maine?
Yeah, today I'm in Connecticut, but I live and work in Maine, okay. Bar Harbor area.
Is this the hot season for Maine as well in January?
Not usually. I think we've had more luck than we deserve this winter. I should probably knock on wood now, but it's been a very mild winter so far.
Okay.
Not too much snow, not too much to complain about. So, and unlike Nick, I don't really miss the snow too much.
Now, what's your role at RockStep?
I'm a software developer there, and I'm helping out with the, I'm kind of jack of all trades, helping out a little bit with everything, but also focusing on this IoT project that we have.
Okay. You jack of all trades. It's funny, that's just what it means to be a software developer anymore. Like, what should I learn to be a software developer? Everything. That's kind of the way it goes.
Yeah, pretty much.
Now, Abigail Ames, you're also in Bar Harbor, Maine. Are you in Maine today?
I am in Bar Harbor, Maine today.
And you're the Director of Technology, is that right?
That's correct.
All right, tell me about the weather. I mean, we might as well just cover it.
Well, I was just going to mention that I walked into work without a coat on this morning, so it has been very warm.
It's freakish, isn't it? It's because of the new ice age. I think isn't that, I don't know. It's hard to keep up. So all of that being said, I would imagine there are a handful of people. So you guys are both with RockStep. I imagine there are a lot of people who don't know who RockStep even is. Abigail, give us the elevator pitch. I just got in. We're going to the 12th floor. So you've got about 60 seconds.
So RockStep Solutions, we build laboratory software for scientific researchers. We're a fairly new startup. We're about 2 years into our business. We are a team of people that have broad experience with research laboratories. So we have a lot of subject matter knowledge going into the business and really good technical knowledge going into it. A lot of us have had experience with gathering requirements and implementing laboratory management systems. So we are building our own from scratch, focused on using the latest technologies, very mobile friendly so that people can use our software and devices right in the laboratories, and also focusing on data monitoring and real-time alerting.
Okay, it looks like you have your work cut out for you. That's quite a bit. Are a bulk of your customers there in Maine, or how did you get started there in Maine?
There's a very large research institution right here on the island that a lot of us came from and have a lot of experience. Our experience comes from there, and we love it here, so we stuck around. But
Okay.
our customers are actually across the country and even some global.
Okay. James, how did you get connected with RockStep?
Yeah, we met them at a event that they hold up in Maine, where they bring a bunch of startups together, they compete together, and I think you guys landed in the top 3. I think maybe, I don't remember exactly what place, but we met you there. You had such a great presentation, and you had you were really thought out on how you laid out all your materials, and so we approached them and we started talking to them about the BizSpark program, which we have, which helps startups get started with Azure credits so that they can start to experiment and grow quickly without having to worry about the cost. And that's how we got started. We got you into that program, and then later on, this new program that we're doing where we're working with startups and other partners to do development work, we thought you guys would be a good
Sure.
partner.
Yeah, and what a great program it is. We get to work with so many great customers building these neat proof of concepts now and really just spanning all these industries. Nick, kind of describe the atmosphere when we began. Like, what we were probably we were testing the water, looking for something. What did you find?
I found a partner that was very eager to learn and innovate, so that was pretty cool, actually. So getting together in the room, I think it's probably one of my favorite formats when it comes to working together. You just lock yourselves up in a conference room. We did so in the Burlington office north of Boston, and yeah, it was great. It was all about pounding away some code, whiteboarding a lot, and coming up with a solution. And the cool thing is that we actually managed to build something in just a couple of days. So that, to me, I think spoke volumes about how, not just, of course, how smart the people in the room are, but also about how technology has evolved to a point where there was a time where the kind of solution that we built here with RockStep is, we never would have dreamed of building this in such a short amount of time. Now it was a matter of, and we were able to turn on a dime as well and say, like, no, let's scrap this component, let's bring this other component instead. And all again, thanks to the power of the cloud and how it truly democratizes technology and makes it available to also very small companies like RockStep.
Sure. Keith, that's what happens, right? You start building something, some great idea, only to realize that you've unlocked a brand new idea that you can kind of chase after. What do you think? Is that the way the world will always be? Are we headed towards where we just can do things so easily now? What's your experience?
Well, so I came. I was new to RockStep at the time. I think I had been at the company for around a month, or maybe even under a month. And my background, was kind of just doing smaller research tools, kind of rolling my own thing with Python. And so it was like a very new technology stack for me, a new environment. And I was kind of aware of concepts of doing stuff in the cloud, but I had never really built anything before that was based on cloud components. And so I was kind of coming into it just trying to ramp up as fast as I could and learn how the different components worked. And yeah, I would definitely echo what Nick said. And also, there's really a rich suite of components. So when we were sort of like designing the architecture and we would find, we hit a technical roadblock, we could kind of look in the toolbox, and I had experts there that understood like what components were at our fingertips, and we could just quickly solve the problem.
Keith, I can already tell I like you, man, because you're designing architecture. You're not architecting. Oh, it drives me crazy when people say architecting like a verb. That's hilarious. Isn't it a luxury, though? I mean, even if looking back, once you know stuff, it's different, right? You're like, oh, yeah, this is pretty simple. But isn't it quite a luxury to walk into something and have somebody with you that already knows it and be able to guide you? You got a guy like James, and you're like, I don't even understand what this is, and he just kind of explains it to you, right? It saves you so much time.
Yeah, it definitely was, and especially because like there's such a rich suite of components. There's like, you have so many choices available to you, and there's definitely a little bit of a learning process there for just kind of figuring out, with this kind of a problem, you probably want to lean toward this kind of a cloud component. Yeah,
it's great to have that kind of solid guidance. Now, Abigail, I feel like most of our economy is made and broken on a whiteboard. It's pretty incredible. What was the initial direction you were kind of hoping to go? What was the original vision?
So we actually applied first for a grant from the National Institutes of Health to solve a very particular problem. Most of our customers have, manage, or use large animal vivariums. So they're using animals for disease models for research. And so we had a particular problem that we wanted to solve that our customers were experiencing. And it has to do with the rate at which they change the cages in the vivarium. It's very much dependent on the levels of ammonia and humidity.
Okay.
And so we crafted up a grant application to try to solve this and some other problems. And that ended up coming through, so we're really lucky to be able to tackle this problem. It's a very new concept to try to use IoT data in this way. When we first started out, we had the original architecture, and that was from maybe 2 years ago. And so many things have changed in Azure since then. So it was really fun to get into the room with these guys. And I think Microsoft was like releasing new Azure components as we were sitting there.
I think during this call, right? It's crazy. Now, all right, let me stop you there. Just kind of talk about what just happened. So, Nick, monitoring cages, that doesn't seem so complicated. What's so complicated about that?
Well, first of all, it's the volume of data. The moment you go into the Internet of Things, I mean, for example, we talk a lot about big data, and people talk about like how to manage the data and how to parse the data and how to report on it. But then, where does the data come from? And it turns out that the Internet of Things is probably one of the biggest creators, if not the biggest creator, of data out there. When you have literally like dozens, hundreds, or thousands of units that are producing data every second, it could even be several times per second, depends on the scenario. Of course, you have to tweak it depending on exactly what you're building. That accumulates pretty fast. And even if you're keeping the data very lean and mean, you're still going to go and get data from a few sensors in that environment and then send it over to the server. And the thing is, with a traditional kind of like web server architecture, any server would just crumble over the weight, under the weight of that data. So that's where the Internet of Things comes along, and that's where Azure has a whole set of solutions to basically help you, first of all, ingest the data. That's the first challenge.
Yeah.
All right, years ago, it would have been really hard.
Let's talk about ingestion. So just in case somebody doesn't know, that means uploading.
Uploading, yeah.
Right? The data comes into Azure, and what's so hard about that? James, walk me through the scenario of why a server might crumble under IoT data.
Sure. So in this case, we have 50,000 different units at any given second sending up data. So they're sending up data every single second, and they're just small little packets. But when you start to calculate how much data that is over a minute, and then you start to think about how much it is over an hour, you've got so much data coming into the system that your standard web server would just absolutely kind of crash underneath that. And so there's a whole bunch of different technologies out there that allow you to ingest this much data. And the one that we ended up choosing was Azure IoT Hub. Okay. And Azure IoT Hub has a whole bunch of other components that are built on top of that.
And IoT Hub sort of reminds me of, I can't remember the bad guy in the Incredible Hulk movie, but remember he was like trying to take the Incredible, he's like, just take it all, and he couldn't take it all, right? IoT Hub's like, just give me more, I can take it, and it never slows down, and it's pretty incredible, actually. It's absolutely incredible. Now, Keith, I want to know your experience here, because did this make it overly complicated? What do you think of this solution?
No, I wouldn't say it was overly complicated. I'll go back to kind of what Nick was saying earlier, where if we were kind of just starting with our programming languages and IDEs, it would have taken forever to kind of put together something like this that was able to scale, and it probably would have turned out to be more of a fragile architecture. So I was personally really happy with how especially the IoT Hub kind of fit into the architecture and abstracted away a lot of the kind of the details of talking to the devices. The devices are just sending up their messages to IoT Hub, and it's kind of easy from there just to route the messages to other Azure components and deal with it that way. And also, the IoT Hub has like really nice capabilities as far as sending messages to devices and, having updates trigger on the devices, which is not something that we implemented in that particular hackathon, but it's definitely going to be something that we're going to be using.
Just capabilities waiting there for you to turn them on, right? That's what's crazy about it. Now, Nick, we live in a crazy world. I was just doing some machine learning, and literally the step was drag on a neural net, and then I'm like, a neural net, and so now we can go in. We need a IoT hub that can take unbelievable amounts of data. Okay, just say new, and what's next? It's just crazy world. So we'll just accept that we're in the world where we can do this sort of rocket ship on demand. What's after ingestion?
Yeah, so just to go to your point here, it's funny because for years I worked in consulting, and we would do these architecture design sessions with customers. So we'd get together with a customer, the Microsoft guys would come in as well, and then we'd spend 2 days architecting a solution. See, I used it as a verb again. So architecting a solution and basically whiteboarding everything. But then after that, we just pack up, and then we would spin up a dev team, and it would take weeks or even months before we actually would see something. Here in the same format, the format is basically the hackathon or the hackfest, as we call it, was basically to get together, and while we're designing the solution, we're also building it, because the cloud really lets us do it very easily. So to answer your question, when it comes to the IoT Hub, you get all this data coming in. You don't have the luxury of simply dumping it into a folder and say, we'll get to it later. You actually have to act on it right away. And that's why ingestion is such a big problem, because the scale of data we're talking about here, for IoT, it's day-to-day scenarios, but in the web, that would be considered a denial of service attack, the level of data that we're getting, So we're actually using a component called Stream Analytics. Basically, it's a set of jobs, one or more jobs that are running, and it's all running in real time. And as the data is coming in, we are taking this data, and then we start basically crunching the numbers and analyzing it basically on the fly. The best analogy I can use is whenever you have, if I give you a parking lot as a developer and I say count the number of red cars, it's not too hard as a developer to write the statement that says I'm going to go through all the cars and count the red ones. If I say go count the number of red cars on the interstate, the idea is going to be first of all, that's a number that's going to change constantly, and you'll need to know between which point and for how long, and that's going to be your answer. So streaming analytics is basically querying moving data, because you don't. That's why we don't call it upload, because an upload has a notion of a beginning and an end, but with this, it never ends.
Yeah,
it's
just
like
a river
Newman
of
and
data.
Seinfeld. The mail just keeps coming and it never stops. So it's the same thing with IoT. The data keeps on coming, and we need to be able to analyze it.
Okay, so James, we have Stream Analytics. What do you do with Stream Analytics?
Yeah, so Stream Analytics allows you to use this SQL-like programming language. It's very familiar to anybody. You could do select star all and dump it into another table. It feels like a table, but you actually hook up these inputs and these outputs. And in our case, we dumped it to a raw database, actually blob storage, so that we could use that to do machine learning and analytics on it later on. We also wanted to make sure, if there's any particular temperature or humidity temperature rating that goes out of whack, then we want to notify somebody so that they can go take a look at it immediately. And I think that's one of the key things that actually brings the business value to the IoT solutions. And I call it the 3 A's of IoT. It's aggregation, analysis, and then action. And if you're not taking any action at the end of your IoT solution, all you're doing is collecting a bunch of data that's going to sit there and nobody's going to look at it. So I think it's that, and Stream Analytics makes it really easy to do the analysis and then be able to send off a notification. I know once we got that notification sent off, Keith, I think you wired in something to actually send a text message to yourself just to kind of do a little bit of a proof of concept. And I remember that was kind of that moment where everything kind of clicked for you guys once we had the data coming from the device all the way through to your phone within seconds.
Yeah, that's cool. Great job, by the way, coming up with a new TLA, because it was SQL on IoT. We're using some sort of AAA. It's great. That's excellent. That's what we need is one more.
We just need one more acronym, right?
Abigail, so we have all this data now, and you can query it, and you can use. What were some of the uses that maybe you didn't anticipate, or you're really glad you were able to do now?
Well, one of the things we realized, so we started out just with this very specific use case using, two metrics, the ammonia and humidity. We decided to add temperature in, and we've been working with University of Michigan. They have a large animal facility, and so we've been talking to them back and forth about deploying these in a pilot scenario. And one of the things we found out was that, he wanted a simple alert if the temperature goes out of range, because they don't have that right now. So that was kind of surprising. It was a surprising, very simple problem that we could solve. And then we sort of got into this, once we realized that we could do this with the temperature and humidity and ammonia, we started thinking of all these pie-in-the-sky sort of scenarios. Like we could add a microphone, we could add a light sensor. We can, the potential for taking these environmental data and starting to overlay them with experimental data and maybe including them with experimental results so that you have better reproducibility. So when a scientist publishes in a journal some experimental results, they could actually include the environmental data with that. So, it opened up, the possibilities are huge for extending this, just from starting out with that one.
Isn't it fascinating how it's funny you say, such a simple problem of what was the temperature and getting an alert, but, if you were to come from scratch and I was to say, hey, I need an alert when the temperature changes, all of a sudden, that's an enormous question, actually. But once you have that in place and you're able to answer little questions, all of a sudden, all these other questions are easy to answer as well. Questions that, honestly, you might have been afraid to ask because the cost, the time, the effort was really unreasonable to get that. And now, all of a sudden, you have access to all these new things. Now, Abigail, tell me, from a customer's point of view, is this going to be, is this a difficult transition for them? Where's the burden?
The burden is really going to be on, so the first round is going to be a pilot to just start collecting the data and see what we have. From that point, it's going to be up to the customer to decide things like the rate at which they want the data coming in, how long do they want to store the data, what is the archive term.
Sure.
They'll have to identify thresholds for alerting. So once they have a sort of a baseline of all these data, they can go in and do some analysis and say, okay, well, this is the mean is standard deviation, and here's where we want the outliers. So that will be, I think, the biggest burden on the customer really is starting to put meaning around the data.
Okay. Now, Nick, this is just a proof of concept, just to make sure that we can tell RockStep this is how you can do it. How difficult is it, how practical is it we could go from a proof of concept like this and scale it to something that could really be used by a company?
Well, actually, it's quite easy because the beauty of the cloud is that you don't design for 10,000 or for 100,000. You basically design for 1 or 5 or 10, and then after that, you can just scale it up. There was a time when architecting for 10 versus 10,000 required a drastically different approach. But the beauty of the cloud here is that you pay as you go. You only pay for what you use. So we don't have to basically make a big investment into initial hardware and knowing exactly, well, are we going to have 100 devices? Are we going to have 10,000 devices? The key is that you're using the cloud. You're using these components that that there's already a team of people at Microsoft that's managing these data centers. And you just scale up based on your needs. So when it comes to designing a solution, it's actually quite easy. The cool thing also is that we had, at first we were going to just simulate the devices, the client-side devices, so we decided let's just create a simple UWP application, Windows 10 app, that would kind of simulate the data by generating random values within a certain range and then send it to the server, until we realized, we got some time, we've got a lot of things are working now. Why don't we take this UWP app and deploy it right away to a Raspberry Pi? Because it's the same model.
Nice.
Because you can actually take a Windows 10 app and it can run on phones, on tablets, on desktops, on servers, and include, of course, on IoT devices like the Minoboard Max or the Raspberry Pi and others. So that was actually, I remember, that was a big haha moment that everybody really loved when they finally saw this running. It was oh, wow, this is running on actual hardware. And I think you guys now are working to basically take this device to the next level to turn it into a production device.
Keith, all I hear Nick saying is easy, easy, easy. You just be the reality check for me. Is it that easy, really?
So, it's obviously work, but I was actually especially the device stuff with putting like the Windows IoT Core on the device and deploying to it. It was actually really fun, and it was easy. And the other thing is Microsoft has created a lot of example projects and stuff like that for IoT. So, if you just Google and hit Microsoft's GitHub repositories, you'll find like tons of examples for, okay, I have like, I want to talk to an SPI or I2C from my Raspberry Pis, stuff like that. So yeah, I mean, it was, it's not like it all just magically happens by itself, but
Sure.
But yeah, it was a pretty easy process.
Right. You weren't all
It
exhausted
definitely
because
helped.
of the effort. Yeah. It's
Yeah, it
pretty
definitely
wild.
helped
It's
to have the
a pretty
experts
wild
in hand.
story to be able to say it's so simple. James, if I had given you a couple of extra days, what do you think you might have done more?
Yeah, the thing I would have liked to do next is, creating what we call ARM templates, which are kind of the automated deployment step of all this. Is we went through the process and we wanted to make sure that they knew all the different components of it, how to actually set it up in the portal and everything. But what you could actually do is take all of these things and turn them into ARM templates and do an automated deployment. And what's really kind of cool about that is that if you set everything onto the free tier inside Azure, you can, with very little spend, you can actually have a development environment right next to your production environment just by clicking another button. So that's something that I get pretty excited about, is being able to automate all this stuff. And I think that would be what I would take for the next couple steps. And Azure actually makes that pretty easily. They have underneath all of the assets that you create in the cloud, there's a little deployment options, and they show you a script that you can then take that and modify a little bit and integrate it into a automated deployment process.
It's that easy, James. It's that easy.
I will. I don't know if that one's that easy, but it's fun, and it's some pretty powerful stuff.
Abigail, it's interesting to me that there's an academic component to this as well when you deal with scientists and researchers. How much value is added when measurements are automated rather than manually gathered?
So we've worked out numbers on this. I can't quote any off the top of my head, but there's a significant value in reduced labor costs. There's also, a concern of ours is reducing the amount of animal waste, so making sure that animals aren't sick or dying unnecessarily. And so there's a lot of value in automating the checking of the cages. So one of the things that came out of this is an add-on grant that we applied for to check for flooded cages.
Okay.
Because right now, it's a manual process. People have to go and look at each cage in order to identify the one that's flooded. And we can easily tack on, a device into this pipeline to start doing that cage flooding detection.
Sure.
So,
And it's even better if it's my job to look for a flood. My rounds are every hour. But if you have a device doing it, its rounds are every minute. It's unbelievable how much quicker it is.
that's right. And a lot of these happen on holidays and weekends when there's reduced staff. So
Yeah.
you're exactly right. Yeah.
Very nice. Nick, what was another part of the architecture that might be interesting in bringing up?
I think it was pretty much like where we would store the data. So we would look at, we have the IoT Hub, but then there's also the event hubs, which are kind of like these transient queues that you can actually use. Because again, when you have so much data coming in, you need to know where to put it because you don't want it to just accumulate and then having too much data to deal with later.
Yeah.
So the event hubs actually were a good transient state to say, let's put them in there. And then after that, we were using these Azure functions to basically act as triggers. So as they were basically looking at the data in the event hub, the Azure functions were then looking for specific parameters, and then from there trigger special actions. So it could be those alerts we were talking about. I remember like on the fly during the Hackfest, we even had the idea of saying like, you know what, instead of just sending an alert to someone to say like this habitat needs to be changed or maybe it has a malfunction, what if there could be an actual light on the habitat itself that could be triggered so that if somebody just walks by, they would see which one it is, or whenever they get there, there's less, fewer chances for human errors where you might end up like changing the wrong cage because you read the number wrong. But if there's an actual light on the habitat that tells you, hey, this is the one that needs to be changed right now or replaced, then again, that was something thanks to those alerts triggered by Azure Functions that we were able to throw in there in a couple days, despite having all that other work that we managed to do in 2 days.
Gosh, and so casually you mention all these massive things. Like, let's talk about functions just for a second. The idea of, I always think of that I Love Lucy episode where she's sorting and wrapping chocolates, and she's going as fast as she can, and all of a sudden all these chocolates start coming down the line. So if she was a function inside Azure, and all these chocolates started, all of a sudden there'd be another Lucy, and another Lucy, and another Lucy, and it could just scale as many as you needed, so everything's still nice and calm, and you never have the hilarious scene that was obviously in I Love Lucy. But that's where functions come up, and you're like, hey, handle this queue. And then I start pouring stuff into that queue. The functions are like, we can do it. No big deal. I'll just clone a brother, clone a brother, clone a brother, clone a brother, and they take care of everything. It's just crazy. All of these components that you're adding to your architecture seem so simple, but they are so massive and solve such a big problem in an easy way. And still, you guys are you say these things like, oh, it's pretty easy, it's pretty quick. It's just amazing. And we live in the brave new world, Nick.
Let's face it also, let's remember that none of us are expert like IT pros at setting up servers and setting up environments. So, I mean, James is a developer, I'm a developer, Keith is a developer as well. Abigail, I know you have a development in tech and development as well. So none of us are experts at setting up servers, and yet we were able to do all of this thanks to the Azure portal and self-service and self-provisioning to basically just like spin up these resources like really quickly. You need a virtual machine, there it is. In this case, everything was, the virtual machines were managed for us, but you want a new event hub, there it is. You want blob storage, there you go. And it's scale as you go, pay as you go, and there's no waste. And also, there's no wait. That's the cool thing. Just a couple minutes, and then boom, the resources are there. Start using them.
The interoperability of the services is amazing. In addition to being able to spin these up really quickly, they all talk to each other. We put Windows IoT Core on the Raspberry Pi. It knew how to talk to the IoT Hub. So that's a huge part of this as well, is everything works together really well.
James, it just works. James, there's a developer listening, and he's like, okay, this is awesome. What would be some advice you'd give to him? What languages do I need to know to be able to make this work?
Well, that's one of the nice things about a lot of the work the team has done is they've opened this up to any language that you might be familiar with. So you can do this in Node.js, you can do this in Python. We happen to be doing it in C# just because RockStep was a C# development platform. And, C# is the best. I'll just throw that in there.
Really? Yeah.
But, no,
what about F#?
Yeah, you can do this in F#. I mean, it's really, but that's the nice thing, and a lot of these devices themselves are actually really low level, and so we have C components, so you can write down right in the nitty gritty and actually work with the core device, make sure that it's doing performance and all that kind of stuff. So
if I'm listening to a solution like this, and I know you're a C# shop, then I'm like, I could really do that. But if I'm listening to it and I know that I'm a Python shop, I could just say, I could do this too, and I don't even need to change all the skill set that I've already invested inside my development team. I can just kind of go for it.
Yeah, and that goes.
Sweet story.
One of the coolest things that goes from the device development all the way up to using Azure Functions. We've got support for Python and Node.js. I think we have support for Bash,
Java as well,
up in Azure Functions, and so Java. So you can do all of this stuff right from whatever language that you're working in, which is really a cool experience.
Yeah. It's a sweet experience. Keith, what's your favorite part of this architecture when you're looking at it? What was the part you enjoyed working on the most?
For me, the most fun part was kind of exploring the IoT Hub and the actual Windows IoT OS, and figuring out like all the different APIs that were available with Windows with the IoT Core version of Windows. I just kind of like to get into that sort of detailed technical stuff, and it was kind of it was cool to me that like the whole stack was available, all the way from the small embedded devices all the way through the cloud and everything, and things just kind of plugged together. So that was a lot of fun. And just to kind of go back, like I was thinking a little bit more about your question about is it really this easy and everything, and I think it kind of like the cloud components. I mean it doesn't make it like things just magically happen. It kind of makes it so that it changes your focus or allows you to almost exclusively focus on the architecture that you want to put together to solve the problem instead of, the infrastructure problems and stuff like that, which I'm sure people like thinking about that stuff. But for me, I'm more interested in
you get to
thinking about the
focus on
components
RockStep, right, and the things that you want to accomplish.
Right.
Yeah, it's so much better. Now, Nick, when I hear him say that, you know what I hear him say? His favorite part was UWP development on Windows 10. I mean, of course that's your favorite, right? It's fantastic. I think you could relate to that. Abigail, what's next for RockStep? What do you see coming next? Maybe something enabled by this or just anything?
Yeah, well, as I mentioned, we're really excited about extending the types of data that we can support through this pipeline, building in some visualizations. That was part of the original plan, and I think we're close to being able to tack on some visualizations onto this. We'd love to, I don't know, you guys can speak more of that. They've been working on it the last couple of days. And we'd love to tie into the machine learning studio. It would be really fun to start taking these data and building machine learning algorithms out of them.
Looking for trends and looking for new answers to questions you haven't thought of yet.
Yeah, what kind of action day.
What kind of, well, maybe Keith, you could talk to me. What kind of visualizations are we talking about?
So, I mean, we were thinking starting off pretty simple, just in terms of like viewing, for example, you can kind of aggregate the sensor data together across multiple devices and then give like a timeline view of how the sensor input has been trending, stuff like that. Or one concept that we have is that you can, the end users should be able to tag their devices in any way that they want. So maybe they would tag them by what room they're in. Maybe they'd tag them by some other factor, by like what organism type was in the housing unit. And then they could kind of look at this sensor data grouped by those. So maybe that would be like a bar plot or something like that exposes the data in those kind of groupings. So and so you can kind of play around with the time dimension, or just kind of look across data in groups, and it looked like all of that was possible with the Power BI stuff. So
nice. Yeah, yet another just small component of Azure. Here we go. Just everything you need in one place. It's beautiful.
Yeah. And it's worth mentioning that the Azure IoT Hubs, the tagging of the different devices and what rooms they're in and all those kinds of things comes along with the management API that Azure IoT Hub comes with. So we didn't actually focus on it during this hackathon, but it's something that they're going to be able to add on to the solution as it grows.
Just another massive enhancement to their solution that's already built into IoT Hub.
If I may add one very important point, because usually the biggest fear that people have when it comes to IoT solutions is security. And this is a solution actually that basically comes secure out of the box. All the devices are actually communicating with the IoT Hub using MQPS, which is a nice IoT protocol that's fully secure. And on top of that, the IoT Hub will not accept any calls, if you will, or any data from an unregistered device. So each device has to be registered. So you get device management so that you can disable a device remotely if one of them becomes compromised or if it fails. You get device security. Well, only devices that are authorized to send you data will send you data. So, because I know that when it comes to IoT, security is usually the first concern companies have. So I just want to put that concern to rest right now because, security is not something that we have to tack on later. It came built in out of the box while we were building the solution in 2 days.
Partly because you're using Windows IoT as well. You already have configuration, management, remote security, everything you need built in that Windows users and Windows administrators already kind of know and love.
Right, but even then, I don't want people to think that it has to be a Windows device on the client side. It could be a Linux device. It could be like an embedded device. It could be anything. And the idea is that all of these devices, of course, will come with different levels of security, but still they have to be individually registered. So there's a way to do bulk registration. But the bottom line is if a device is not authorized to send data, it cannot send data, or the IoT Hub will simply reject it. And it's built to design. It's built and designed to basically handle all of that without crumbling under the weight of like rogue devices if somebody tries to do some kind of an IoT attack against your infrastructure.
Yeah. Wow, that's beautiful. James, great job, man. You're my favorite evangelist, no doubt about it.
Yeah, Nick is my favorite, so I think we've got it.
Nick, great job too. Hey, thanks for being on the show, you guys. This was really a fascinating solution that it's funny how every company is so unique and every company is just the same. You know what I mean? Keith, thanks for being on the show. And Abigail, thanks for being on the show too. We're excited with what's next with RockStep.
Thanks a
Jerry.
lot. It was a lot of fun kind of talking about the experience we had and working with all the Azure tools and all that.
Cool. Thanks, guys. We'll see you again.